Hello. This session I'm going to cover image processing options. We have two options in Fusion for BC43. We have deconvolution and stitching. I'm going to start by explaining deconvolution to you. So here on the left I have an image that's currently actually in epifluorescence, so in a wide field mode. You can see that compared to some of the other images you've seen in our sessions, here the signal from the sample, or the detail in the sample, isn't particularly sharp, and you have this hazy out of focus information. And what deconvolution will do will be to clean up this image, removing the haze and improving the resolution of your image. Times you might want to use epifluorescence might be when you've got live cells, for example, and they're really sensitive to light, and maybe for some reason the confocal illumination is too harsh for them. And so you can move to epifluorescence and image your cells in epifluorescence, but then you still have the ability to use deconvolution, as you shall see shortly, to improve the resolution of your image. Other times you might use it again as if you have a sample that's very low in signal. Maybe your fluorophore expression is really low, or your signal is really low, and therefore you need to use epifluorescence to get as much light as possible to the camera. But again, you can use deconvolution to improve the quality of that image. So I've actually just previously set up a Z-stack. So what I'm going to do is acquire that data. So you can see me running through the Z-stack, and you can see that it's hazy and out of focus. And now I'm going to go to deconvolution. I can trigger deconvolution to run immediately after the protocol is finished, but I'll take an opportunity to show you this image processing tab up here. So I've gone up to the top of the screen to the right, and now I've got access to deconvolution, what we call clear view, and stitching. So I want to show the clear view deconvolution. So this is a GPU accelerated deconvolution, so we can deconvolve exceptionally quickly using a GPU processor on a dedicated graphics card. And we can just go with the default settings where we've got pre-sharpening on, 10 iterations. So 10 iterations means it's going to go through 10 cycles of refinement in the process of deconvolving our image. If you want a clearer image, then you can increase the number of iterations that you make. That will take a little bit longer. So you can choose the number of iterations according to how much detail you want to see in your image and how long you want to wait. And then you can choose to use pre-sharpening in your image or not. Pre-sharpening, you can play with either switching it on or switching it off. Sometimes if you have a noisy image, then pre-sharpening can help a little. But if you've actually got a fairly clean image, then actually switching pre-sharpening off is probably the better option. Your result will be better. And then also we have something called a deconvolution preview mode. So I'm going to switch the deconvolution preview mode on, and what you'll see is a second window open up on the right with your original data on the left. And you can use this to just very quickly sample how your deconvolved image is going to look. And then using this, then you can try switching, for example, the pre-sharpening on and off to see what impact that has on your image. You can zoom in if you so wish to get a better idea. So I can switch pre-sharpening off and pre-sharpening on, and then I can also, for example, increase the number of iterations, and I can see what effect that has on the image. So having made whatever selections I wish to do, and assuming that I'm happy with the end result, I can now simply go to deconvolve, and the deconvolving algorithm will work on the image, and you'll see it appear very shortly here on the right hand side. And what it's now doing is deconvolving the whole volume, so it'll be working sort of sector by sector in terms of the size of the image laterally, as well as then working its way through the Z-stack. If I go, for example, to the 3D view, I can see that whole image building up, and I can even inspect it whilst it's imaging. So now that's finished deconvolving, so you can quite clearly see the difference between the starting image and the ending image, and how much clearer that final image is in terms of detail. In terms of structure here, can you see around the edges of these chambers, pollen chambers? So that's deconvolution. So now I'm going to show you Stitcher. So here I have a sample of cells, and what I'm going to do is Stitcher will stitch together a tiled image. So this is when you want to capture more than just the field of view of your objective. So I'm going to actually capture basically a field size of 2 in X and 2 in Y tiles to give myself a bigger image. So here you can see that I've hit montage, and you can see that I have a 2 by 2 tiled image that I'm going to capture. And then I can, if I choose to have it as part of the protocol, I can actually apply Stitcher here, for example, and then Stitcher will automatically apply, as soon as the experiment's finished capturing, we'll start stitching the image. I'm not going to actually choose that here because at the end of the experiment I want to explain Stitcher to you in more detail. So the first point is that I need to capture my data set. So I've got a small Z stack and my montaged image. So I'm just going to go to display all here, and then you'll see the images capturing as they create. So I've got 2 channels, a green channel and a red channel. So it's just going through the 4 tiles. Okay, so it's captured all 4 tiles. It's not stitched at the moment, and you can tell because if I zoom in, you can see that we have little bits of overlap on the edge. This is just butt stitched, so it's not actually stitched yet. So we can zoom back out, and what we're going to do is we're going to go to the processing tab here, and we have stitching, so we can reveal Stitcher there. We have a choice of 2 modes. We have a high quality mode and a high speed mode. They do what they say, so high quality will give you the best accuracy of stitching, but it'll take a bit longer to process, or high speed will give you something quicker, and it just depends on your needs and how quickly you need to see a result. But let's go with high quality. And then the other choice you have is select which channel you want to stitch by. So, what's your reference point to stitch? And the reason you might want to choose here is if you choose auto, what will happen is that Stitcher will automatically choose the first channel in your protocol, in this case green, to stitch. But if you choose user defined, then you get to choose whether it uses the red channel to stitch by or the green channel. Why would you choose a specific channel? Stitcher will always give you the best results when you have a sample with the most amount of detail in it. So for example, if you have one channel that has very little detail in it or very sparse data, but you have a second channel where you have a lot of information, both spatially maybe as well as also signal, then it's always wise to choose the channel with the most image information in it. Now both of these channels in this particular sample are good, but as you can see the red channel does have more spatial spread, if you like, and so I'm actually going to choose the red channel to stitch here, though Stitcher would handle both perfectly well. So I choose user defined, I hit stitch, and then I can select my channel. So as you saw, it defaulted to green, but I'm going to choose red, and I hit select channel, and now it will start stitching. And if you look carefully, you'll see very quickly the end result, and you'll see that this area here, for example, where you saw a duplicate, is now perfectly stitched. You can't see any area here where there's any mismatch. Stitch has done a great job. And if we go to we are in the 3D view actually here, sorry, already as well, then we can rotate the image and you can see from every angle, the Stitcher has done a great job. And the way Stitcher works is that Stitcher is very good at imaging. It doesn't just match in X and Y, but it also matches in Z as well. So you get a good 3D stitch.